Today, I'd like to show how you can use simple phone blocks to explain multiplication, division, and the relationship of multiplication to division, the inverse relationship. Let's start out with multiplication. Here we have a concrete example of a multiplication problem. And multiplication is normally explained with the standard multiplication model that basically says 3 times 4 can be represented by 3 groups of 4 items each. It's a great model, and really it gets to the heart of what multiplication is. We can test it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's a valid model, and basically using this standard multiplication model, we can see that multiplication is simply another name for counting. Or we could say it's simply another name for adding. Here we have 23 times 157, and we could see that it could be looked upon as an addition problem, where we add 157 to itself 22 times. Looking at this addition problem, it would be a Herculean task to try and add it up. So we can really appreciate that the simple rules associated with multiplication, we can appreciate how valuable they are. Now let's discuss division. Can we use this model to explain division? Well, you might say it's intuitively obvious, but to me it's not really obvious. I would tend to explain it, and it's not a very good model at all, by dividing both sides of the equation by 4, and that would result in, well, dividing both sides of the equation by 3, and that would result in a quotient of 4. Quotient means number of times. But that really isn't a satisfying explanation. We could do a little better by using the multiplication table as teaching aid. And we can see that 12, if divided by 3, would have a quotient of 4. But again, that's not really as good a model as this model here. Let's look a little closer at our problem here. 3 times 4 is equal to 12. This has the characteristics of an area problem. If we have a rug and it's 3 feet wide and 4 foot long, then we have a square area of 12. Now this is making more sense. Let's modify the multiplication table to represent area. Before, we had the multiplication table was populated with counting numbers, and now it's populated with shapes. These shapes are squares and rectangles. They have different dimensions, different sizes, and they also have different orientations. Now let's take 3 times 4, and we're here, okay? Or let's do 4 times 3. First we take 12 blocks, and we build our base of 4. This is our divisor. And then we continue building the rectangle until all blocks are used up. And we end up with a 3 by 4 rectangle. So we can see that the base, or the divisor, which consists of 4 blocks, is contained in the rectangle of 12 blocks 3 times. To me, that's a clearer way of looking at division. Now, this particular model can be used for a lot of things. For example, factoring. Here we have a 1 by 12 rectangle. We can make a rectangle of a height of 2, like so, and we can see that factors of 12 include 2 by 6. And we could extend a little further. We could make a rectangle with a height of 3. The factors here would be 3 and 4. So we can see that if we wanted to factor 12, the factors would be 1 and 12, 2 and 6, and 3 and 4. We can also use this model to introduce fractions in multiplication. Multiplication requires forming a rectangle. What are we going to do if we have 7 blocks? In other words, how are we going to express the multiplication problem that would have an answer of 7? Well, we want to form a rectangle, therefore we could cut the green block in half, put half here, half there, and now we have a rectangle with height of 2 and length of 3.5. Or we could cut it into 3 equal parts. 1/3 here, 1/3 there, 1/3 there. And now we have a rectangle of 3 times 2 and 1/3. That would be equal to 7. This model is interesting, and thanks. Bye.